What we're going to focus on today is going to be Ansible. We'll be focusing on a version control system. That PC must have been a Windows machine. And then using that, you kind of connect with your infrastructure devices. So it can be, for example, a router. And then that router has either SSH configured on it, then it has along with that either netconf or it has restconf configured with it. So that's your destination. We can say that this is going to be considered as a client, and that's going to be considered as a server. So on your client machine, you've been using lots of tools, including Python, right? Including Postman, an IDE that has been VS Code for you, in which you've used libraries like NetMiko, then NC client, then requests, right? All of these is something that you've been interacting with for 4 days, last 4 days. And then using this, you have been pushing the configuration and pulling the configuration and then performing your operational tasks. In addition to that, what we're going to learn is we're going to just deviate from the standard ways of what you've been doing to a new way of how Ansible generally is used. Now, you shouldn't really consider that Ansible is something better than your existing tools that you have learned because all of them work parallelly. It's just their mechanisms and architecture is a bit different than what you have learned so far. When we look at model driven programmability, why we consider model driven programmability is a better way than iOS automation, because in iOS automation, when we use libraries like NetMiko, we are able to pull out and push configuration onto network devices or push pull configuration from network devices. But whatever interaction happens between our client machine and our server machine, that kind of interaction is very raw, which means the raw data is exchanged. Your client PC finds it difficult in order to deserialize or in order to understand the data that actually is being sent or is being received. And hence it is unable natively to process that data and take certain action against that. One of the examples here I might have told you, or I tell you, that whenever you try to fetch some data, let's say there are 100 devices, and on those 100 devices, you're kind of performing uh, a task that you need to check every night between a maintenance window of 12 a.m. To 2 a.m. that whatever devices are available in your inventory, a script gets executed, and that script checks what all are the interfaces which are up or which are having administrative status as up, and then find out if there is any interface whose administrative state is up and line protocol is down, or find out if there is an administrative state of an interface that is up, but there is no IP address configured, right? Such kind of information is something that you're willing to gather. And then create a list of such interfaces. And when you create such list, perform a task to turn off these interfaces, right? If there is no IP address, but the admin state is off or so. So such kind of tests can actually be done only and only if your client machine understands the data that is being returned out. If the data is not being understood by your client machine, then you cannot really program it to achieve certain tasks or a followed up tasks for that matter. So that's exactly where structured data languages comes up, where XML and JSON gives your client PC an ability to understand data, and even it gives ability to your server or to your network infrastructure devices to understand the data. So when the data that is being sent out or data that is being received is written in XML or is in JSON, your client PC as well as your server PC are more likely to understand that data and then process that data and then can take certain actions against that data. Then the use case or the example that I was stating right now, that perform a task which fetches out all the interface details and then takes certain action onto that particular interface configuration, you can achieve that easily. That's exactly where model driven programmability comes into picture. And to achieve this motive, the configuration needs to be validated, that whatever configuration you are pushing or pulling from device or to device needs to be in a structured format. So Yang comes up as a validator, as a data validation language or so. And netconf and restconf acts majorly as a transfer protocol, but they are considered to be as network automation protocol, of course. But they use a protocol stack. When you use netconf works with XML and works with Yang. That's the protocol stack of netconf. The restconf uses HTTP as its transport, uses JSON majorly, and then Yang. Similarly, netconf in its transport uses SSH combined with XML and with Yang. That is how netconf and restconf generally works. But now, what about Ansible? So in Ansible, uh, majorly the things are going to be same, but you're still achieving the same motive, which is to push configuration or fetch configuration to or from network devices. However, the tools that you consider using are going to be different. In this case, you need to understand certain Ansible terminologies. So, like I said, before jumping into Ansible, we first need to understand certain Ansible terminologies. In that, when we understand the Ansible terminology, so terminologies are nothing but certain um, lingo things that you need to go through. So number one, in Ansible, you will have something called ACM. ACM is going to be Ansible control machine. Okay, I'll explain what that is going to be. Then you're gonna have something called MN, which is managed nodes. Can be one node, it can be multiple. Then you're gonna have an inventory. Okay, doesn't really have any definition, but I can say list of network devices. And you'd have a playbook, which is again list of tasks. Okay, or rather they are also referred as plays. It can again be one task or so. So it's just like you have one playbook. Inside that particular playbook, you're gonna have a play. Inside that play, you can have task number one, task number two, or so on. So you have a play, and outside you have a playbook. This playbook is always a YAML file, just in the case of Ansible. Now we will learn how YAML works or how YAML comes into picture or so on. But what is ACM? Is Ansible compatible on all the devices? Or is it just executable on XC and XR and NXOS? That's that's exactly where Ansible plays an advantage of role in comparison to iOS automation or model-driven programmability. Because having Ansible is not a dependency onto network infrastructure devices. Ansible must be available on your client machine, whereas netconf, restconf must be available onto your network infrastructure device. So that's where the limitation goes off. So you need to make sure that Ansible is installed on your client machine, and you don't need to have Ansible installed on your network device, be it a router, switch, or anything. What you need, since Ansible uses SSH again as its transport for making communication with the device, which is available on any network device. Ansible control machine natively supported on Linux based platforms, which means it is available on operating systems like Ubuntu, operating systems like Mac, but it is not natively supported on Windows devices, which means you cannot install Ansible on Windows device until unless you have a workaround for installing it by using Linux tools such as WSL, which we're going to use, Windows Subsystem Linux. You kind of install Ubuntu in a very lightweight container form, and using that in your Windows machine would help you to uh, run Linux programs onto your Windows machine. But again, natively, Ansible is not supported on Windows platforms. It is only supported on Linux machine. So you need to make sure that your client machine is a Linux machine or is a Linux supported box. We right now are using Windows 10 machine, so we cannot natively install Ansible on that. Okay. So wherever you install Ansible, that particular machine is going to be your Ansible control machine. Then after that, manage nodes is nothing but the devices that you're going to manage. So if you have R1 there, this is your manage node. If you have R2 there, that is your manage node. If you have R3 there, that is again your manage node. So whatever devices that you're interacting with, those are going to be your managed nodes. All right. So ACM is going to again be your client machine. Managed node is kind of going to be your network infrastructure. Inventory is going to be a file which has list of all the devices that you're going to manage. For example, you have three devices, R1, then R2, and then R3. R1 has an IP address of 10.255.1.101. R2 has 10.255.1.102, and R3 has 10.255.1.103, right? So maintaining an inventory of management IP addresses is something that's going to be there. So I might create a file like hosts under a folder called inventory, right? And then in that particular host file, I'll be having all the details of all the management IP address for the routers or switches or whatever devices that I have. So that is again a necessary thing that you should ensure, which is available on your ACM. Okay. In this device, you are going to install Ansible, then you're going to maintain an inventory against which configurations will be executed. So ACM, inventory, manage nodes, and then playbook. Playbook would also be something that is maintained on your Ansible control machine, because the playbooks are going to be with .yml extension. So it can be any name .yml, because these are mostly YAML files. Now, how YAML works and what you can compare it with, all of that is something that we will learn. ACM is going to, so for us now, what we generally have in our lab environment is we kind of have a Windows 10 machine, and we have an EVE-NG simulator, right? The Windows 10 machine is exposed out to the iNet or internet from our data center, and that's exactly where you are sitting. And what you're going to do is you are basically going to RDP onto the Windows machine. That's what you've been doing. And from this Windows machine, you access the EVE-NG. In EVE-NG, you kind of create the topology. And in Windows 10, you use tools like Python and VS Code and Postman blah, blah, blah. In the same machine, what we're going to install is WSL, which is already installed, I guess, in your machines, which has its full form called Windows Subsystem Linux. This Windows Subsystem Linux provides you an Ubuntu terminal. Okay, and you can install as well as use all Linux utilities, Linux native utilities inside of that particular machine. So you don't necessarily need to change this Windows 10 and install an Ubuntu machine or so. No. In the Windows 10, you can install WSL, which is free of cost. If you just Google that how to install WSL, it is just going into Microsoft Store, searching for an application called Ubuntu, it install and it is done. However, it does require virtualization to be enabled on your PC if it hasn't been enabled. So as a lab limitation, in your machines, if you try that, using the CSR devices, which again requires nested virtualization, and the Ubuntu box would not be possible at the same time. So you'd be testing all of the tasks related to Ansible on iOS devices. Although there is not going to be change of configuration of playbook creation or so, if you intend to do it on iOS XCXR or so, whatever playbooks that we create for iOS, those will work for iOS XCXR and XOS as well. There's no configuration or scripting difference between them. So we're gonna kind of install our Ansible into this particular device. So we would see Ansible will be installed. And then here we're gonna have a topology, of course. The topology that you guys must have been using so far is, let's say you have router 1, then you have router 2, and then you have router 3. All of that kind of connects to an interface called Cloud 1, and it goes here, right? And then the Cloud 1 is going to be connected out to a Windows machine. Inside of that Windows machine, you're gonna have a WSL. That WSL will have Ansible installed inside of it. So the major thing is, from this Windows machine, you have been doing SSH onto the device. But Ansible would require that from WSL, you should be able to do SSH onto these devices. If you're able to do that, which means when you execute your playbook from or within WSL, it goes out to your evng topology and pushes or pulls configuration to or from your devices. Okay. Now the WSL can speak with the Windows machine, which means from here you can communicate inside the WSL, because WSL is nothing but a terminal, just like CLI, just like command prompt. So you do not have any GUI in the form of WSL also. It is just all commands. But we need to write down playbooks or things like that, for which we need help of VS Code or things like that. And VS Code is installed in your Windows machine. Ansible is installed in your WSL. So until unless the Windows machine speak with the WSL, that usability would also not be possible. So you can manage the files and things that you create inside the WSL from Windows. That is very much possible, which will allow us to perform the labs in a virtual environment pretty smoothly. It's not going to be a barrier for us. So we would learn these things, that how we can communicate with how we can kind of interact with the Windows Linux subsystem or Windows subsystem Linux in the Windows machine, and then kind of create a topology. Make sure you're able to SSH to the topology from your WSL, and then install Ansible on it, and then maybe create necessary files and perform configurations onto your devices from Ansible. um, inside your Windows or WSL. That's going to be our tasks.